The expo on your next trigonometry test. We've done number 1 and number 2. So let's get into the third one. Here, you're told to prove that cos cube x plus sine cube x over cos x plus sine x will give you 1 minus sine x cos x. So again, we're going to take the left hand side, which is cos cube x plus sine cube x over cos x plus sine x. So we're going to try to prove that this is equal to all of this here. Okay, so we want to do the algebraic stuff before we do the trigonometry stuff. So if you look at the top here, the numerator, this is one of those binomial identities things. Some people will do something like cos x plus sine x equals to cos square x plus sine square x. This is wrong. You don't do this. It's completely wrong. This is wrong. So don't do this. This actually opens up to, so if you have, let's say this, what this opens up to is x plus y cube minus 3xy x plus y. So the expansion for a cubic expression like this is this. So when we want to expand what we're given here, that's how we expand it. So cos cube x plus sine cube x will therefore be, rather instead of x we write cos x, instead of y we write sine x cube, then 3, instead of x we write cos x sine x, then in this bracket we'd have cos x plus sine x. So all of this would now be the numerator. See why I said this is what your teacher will set in the next test? Because it looks hard, but it's actually easy. So let's go cos x plus sine x all cube minus 3 cos x sine x cos x plus sine x all over cos x plus sine x. So we're still doing the algebraic stuff now. If you look closely, you'd see that cos x plus sine x plus x plus sine x is factorizable. So you bring it out, cos x plus sine x, you factorize it out, we factor it out, then you would have cos x plus sine x all squared here minus 3 cos x sine x all over cos x plus sine x. So you can clearly see that this and this will cancel. So up here you have cos x plus sine x all squared. Let's open this bracket, minus 3 cos x sine x. Here we're going to have to open this. So I taught you how to open this easily. This will be cos square x plus 2 cos x sine x plus sine squared x, then minus 3 cos x sine x. So we can restructure this as cos square x plus sine squared x plus 2 cos x sine x minus 3 cos x sine x. So we do the trigonometric stuff I've been talking about here. You recall that, I'm sure you know, that cos squared x plus sine squared x is 1. So instead of this, I'm going to have 1 here. Then on this other side, these two are the same. 2 cos x sine x minus 3 cos x sine x. That will give you minus cos x sine x, which can be written as 1 minus sine x cos x. And that's the proof. You have proven that this is equal to this. Again, you're welcome.